So guys, you see how simple this is? You see, it's not that difficult. You just have to concentrate on what you're given, what is required, what is the proper setup. Keep practicing this because remember, if you don't understand the foundation, guess what? You're not going to understand anything else that you have to do as it relates to these chemical equilibrium problems, along with the ice chart. Okay? This is your next problem that I want you guys to do right here. Number 4. Okay, number 4. So let me go ahead and kind of make this a little bit smaller for spacing purposes. Okay, there we go. All right. So for number 4, right here, number 4. Oh, thank you. Thank you. All right, Jayla Bug, you're learning this right now. Good, 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 good. All right. So let's take a look then at this next problem. Again, I don't want you guys to overthink this, okay? I want you to take your time and go through it. Here's your reaction right here. PCl5 is in equilibrium with PCl3 and chlorine. All right. Now, you remember, it's products over reactants. Okay. In this case, your reactants are still on the left-hand side, and the product is still on the right-hand side. All right. Now, what we're going to do, we're going to set it up again. Equilibrium constant. Oh, and look at this. They're asking you to calculate the concentration of PCl5. But that's okay. We can do that. Here's why. We know that we're going to put the product, which is PCl3 times Cl2 divided by PCl5. Now notice, we do not have any coefficients, therefore we do not need to have any exponents. That's a good thing. There aren't any coefficients in our balanced equation, therefore we don't need to have any exponents. Now, they're wanting us to look for the concentration of PCl5. So basically this bottom number right here. So you know what we're going to do? We're going to swap these two right here. We're going to swap them. So that means I'm going to rewrite my formula, okay? So that's going to be PCl5 equals PCl3 times Cl2 divided by Kc. Okay, I'm going to let you guys marinate on what I just did. I swapped the bottom number, the bottom component for Kc because they want us to find PCl5. So we rewrote the formula, okay? So by us rewriting the formula out, we're going to now use the new formula with the numbers that are given. So PCl5 equals, let's go up to our numbers here to see what we were given, okay? We're given PCl3, we're given Cl2, and we're given Kc. We're going to plug all three of those numbers in to our problem. So PCl3 is 0.125 times Cl2, 0.125, and then divide that by 0.0870. All right, so let's plug these in. Let's plug these numbers in to see what we get right here. I'm going to go ahead and plug it in to my calculator. 0.125 times 0.125 divided by 0.0870. We only need two of those numbers, guys. So we end up with 0.18 molarity. That is our answer right here. This is the answer. Okay, 0.18 molarity. And remember, put those units there because your teachers may take off points. Okay? If you don't include your units, you've got to put your units there. Okay? Put your units. Make sure you include your units. What you got to remember, if you put the 0 on the end of that number, if you say 0.180, that's going to give you 3 significant digits. The reason why we have to do, oh, you know what? Oh, my bad, Francesca. You still in here. I'm so sorry. You asked, I thought it was 3 sig figs. You're right. It is. My bad, honey, my bad. So yes, this goes back to our answer then. The answer should have 3 significant digits. My mind was still in the first one that had 2. So yes, Francesca, you are right, honey. Give yourself a hand. You were right. You were right. It should be 3 significant digits. Yes. Yes. Look, teachers are not above correcting, okay? Teachers make mistakes, so don't feel bad. If you see that the number is wrong, speak out. Same thing with doctors. If they write a prescription wrong, most of the time the nurses are going to recognize that. Nurses don't get enough credit. Okay, so yes, Francesca, you were on it. So now, y'all, let's look at the next one. It says, write the chemical equilibrium expression for the following involving a solid. Who can answer this question for me? Oh, good, Ash. No solids or liquids are included. That is correct. Bing, 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 bing. So the only thing you're going to have in this chemical equilibrium expression is just simply carbon dioxide, and that's it. That's your answer right there. Okay, so this is for number 7 right here. And it says, select the correct equilibrium constant expression for the heterogeneous reaction. Okay, well, we just had a pre-problem that kind of set the tone. When you write this out, remember, do not include your solids. So you guys remember, we've got to exclude. We've got to exclude the solids. So we're going to go ahead and cancel those out so we don't process that in our mind. Now, guess what else we can do? Because we know we are excluding those two, look for water on top, hydrogen on the bottom. Also, because we have excluded iron or an iron oxide, guess what we're going to do? We're going to get rid of any answer that shows them in their answer choice. So we're getting rid of any of those that show that in the answer choice. So you see, we swapped out A and C. Okay, so what we're going to do, on the very top, we're going to put H2O, raised to the power of 4, and H2 raised to the power of 4. So yes, the answer is letter B. Otherwise, if you chose letter D, you would be saying that the reactants were on top. But remember, it's products over reactants. Okay? Products over reactants. All right, so here is your problem here. I always go through and highlight things that I know I will need for the problem. Okay, I'm highlighting things that I need for this problem right here. I'm going to highlight in a different color what we're looking for. Okay. I'm going to let you guys marinate on the details before we figure out how to set this problem up. Okay? So here we go. It says the equilibrium constant for the reaction hydrogen plus iodine gives you hydroiodic acid. The Kc is 49.5 at a certain temperature. If the equilibrium mixture contains hydrogen 0.010 molarity and iodine 0.010 molarity, calculate the concentration of Hi. So now you all know the formula for this again is Kc equals products, which is Hi, raised to the power of 2, divided by your reactants, which is H2, times iodine, I2. There aren't any exponents in my reactants, so that's why I don't have to have exponents there. But also look at what they're asking you to do. They're wanting you to do what? Find Hi. So what am I going to do? I'm going to multiply these two right here, or these three rather, right here. I'm going to multiply those three numbers. Okay, watch how I rearrange this formula. Okay, I've got HI square equals KC times H2 times I2. Okay, now this is the formula right here, guys. You see that? But you see where there's a square right over there, right? We are going to get rid of that square by taking the square root of the other side. I'm going to say it again. You see where it says x. Matter of fact, let me just write this so that way you can see it. It's saying x squared equals to, let's say, a times b times c. Well, we don't want to have x squared because we're trying to look for that particular number. So what we're going to say is we're going to say x equals the square root of a times b times c. Okay? I'm going to let you all marinate. I'm going to pause my mouth for a second so that you guys can marinate on what I just said. Okay? I want to make sure that you guys can digest that. All right, now let's finish this problem off right here. Okay, let's go ahead and finish it off. So for number 7, number 6. What we're going to do, we're going to take that formula right there, HI. This is what it was over here, guys. I'm going to rewrite it so you all can see what I'm doing, okay? We're going to take the square root of that. So we're going to get rid of that square. So the formula becomes HI equals the square root of KC times H2 times I2. Okay? You all see that? Okay, now we're going to plug in our numbers. We're looking for HI. All right. The KC that they gave us was 49.5. So we got to write that in right here. 49.5 times the H2 that they gave us in our problem was 0.10. Let me go back and look at the number again. Hold on, y'all. 0.010 times I's number, which is also 0.010. Okay. HI equals, so let's go ahead and multiply all these numbers here, okay? Let's go ahead and plug in all of our numbers. We're going to say 49.5 times 0.010 times 0.010. All right. The square root of all of those numbers is 4.95 times 10 to the negative 3. HI equals the square root of that number. And this is 0.0704 molarity. And just like that, we are done. So just to recap this, okay, this was our problem initially. The equilibrium constant was this formula here. They gave you the number. And then they gave you the concentrations of 2 of the 3. They wanted you to look for the third number. So how did we do that? Well, we had to come over here. And I'm going to put this in a different color. We had to come over here. This was our original formula right here. But what do? We actually had to rewrite it so that we can get HI by itself. And that's what we did over here. And so after we rearranged the formula to get HI by itself, we ended up multiplying KC times H2 times I2. And now We don't want a square. We don't want to say x squared equals a times b times c. Instead, we got to take the square root of the other side. And now, when we take the square root of the other side, that gets hi by itself, which is what you guys see here in blue. And then we finished it out. Make sure that you take your time when you do these chemical equilibrium problems, okay?